Okay, here's the homework help video for homework 1.5 in physics. We'll start with number 1 here, and again I'll get you started on each of them. I won't finish any of these problems for you. So number 1 says we have a 50 Newton package tied with in the mail, tied with string that goes around each side of the box. And when Irma lifts the box by the string in the center so that the piece of string makes an angle of 45 degrees with the vertical, we want to know what the tension is in each piece of string. Now the important part here is to realize that we have 4 pieces of string that are holding the weight of that box. So each string is going to carry 1/4 of the weight. So if we go to this scenario here, we've got 1/4 of the weight as the vertical component of the tension in this rope. And then we're also going to have a horizontal component, and then here is our string, and we've got our right triangle here. We know that this angle is going to be 45 degrees, this angle is going to be 45 degrees. So if we redraw that real quickly, we're looking for T here. We know that this is going to be 12.5 newtons because it's 1/4 of 50. And that is enough, since we know that these two angles are 45 degrees, to solve for T. If we look at the second one here, we've got Travis that's stuck his car in the mud, and it says if Travis can exert a force of 610 newtons on the rope, moving at 1 meter in the direction shown, and we're going to say he's moving into the board. I just can't draw an arrow that looks like that. He's going to move into the board. How much force will the rope exert on the car? This is going to be a lot like a couple of our homework problems from last time. Excuse me. We know, and I'm going to redraw this rope just for the sake of seeing it in a different light. We know from and this is from the picture, that he pushes it 1 meter in that direction. And we know that this distance is 6 meters, and that this distance is 6 meters. So we know that he's exerting a force of 610 newtons, and he moves at 1 meter in the direction shown, and that we have 6 meters as that other leg of our triangle. So let's redraw that triangle to solve for an angle. We know that this is 1 meter. We know that this is 6 meters. So we should be able to solve for theta. Once we solve for theta, we need to draw that same triangle again with theta. And we know that leg of this triangle because we know how much force Travis is exerting on it. That's all I'm going to give you there. I think you can solve it from there. The next one has a wrecking ball. It's a 12,400 Newton wrecking ball, and kind of as an interesting side note, I got this problem from the book, and they used mg as the way to denote the 12,400 newtons. Mg is just another way to say the weight. It's mass times gravity. It's another way to say how much it weighs in newtons. So that mg equals 12,400 newtons. And if you're interested, we don't know the mass, but we could find it because gravity is always 9.81. And we won't worry about the units on that for right now because we haven't talked about it. But 9.81 is gravity. So we've got this wrecking ball that's 12,400 newtons, and we want to know first what angle the wrecking ball makes with the vertical when it is pulled back. Now this triangle is a little bit flipped for us, but I think we can figure it out. If we redraw that and show it on top, I think it'll look a little nicer for us. So we've got a vertical component of the tension, and we've got a horizontal component, and we know that it's a right triangle. The vertical component is going to be that 12,400 newtons because that's how much it weighs. the horizontal component, it's pulled back with a force of 5,480. So the horizontal component is going to be 5480. Using this, we can find this angle. We can also find this angle, and we can use that to find that angle. There's also another way you could do it. If you prefer, we could draw our triangle down here and do the exact same thing. It would be more of a one-step thing, but I think this drawing up here shows it visually a little bit better, but that's just a personal preference. If you want to draw it differently, that's okay. It also asks us what is the tension in the ball's supporting cable when it is at this angle, and I think once you find the angle and once you get this set up, you can go ahead and do that one on your own. The last one here, and this is by far the toughest one, I think, at least to visualize and get started on. We know that Malcolm, the 200 Newton monkey, hangs from the jungle vine, and it asks us what is the tension in the segment of the vine labeled AB, and we've got A, B, C there, so AB, and then what is the tension in the segment of the vine labeled BC. We've got to remember a couple different things here. First, we're going to have to remember the parallelogram rule. We're also going to have to think about resultant force, and then we're also going to have to think about which segment should have the most tension. The segment that should have the most tension is AB because most of Malcolm's weight is hanging on there. So we'll draw a little bit longer line in that direction, and that'll kind of be our vector. There should also be some tension on the 60-degree line, so we'll draw a slightly shorter vector there. The other thing we need to remember is that the resultant force on Malcolm, he's not moving, so the resultant force has to be straight up. It's got to be right there. And if we think parallelogram rule, our other two lines are parallel and of equal length. So there we have our parallelogram. Now, fortunately for us, that's a rectangle, and we know this angle is 30, and we know this angle is 60. This problem starts to get quite a bit easier because we also know that this angle is 60 and this angle is 30. We also know that the diagonal of this rectangle is 200 newtons. So I'm going to redraw our rectangle here. We know that this is 200 newtons. Once we get that, it's simply doing a little bit of trig identity math. We know all the angles. We know the hypotenuse, as it were, this line right here. So at that point, all it is using some sine, cosine, tangent to solve for this leg and this leg. I'll leave you with that. I hope that helps. If you have questions, please come ask me, and I'll see you tomorrow.